Hello, beautiful people. My name is Dave Price. I'm a instructor, math teacher, math and science teacher at Vision's Virtual Math and Science Center. And I want to show you a little project. It's a solar UV disinfection water system that myself and my students collectively we designed and built last year, my ninth graders. This is a solar panel. You don't have electricity, you can get it from the sun. It powers this battery right here, which stores electricity, obviously. And we need that battery 12 volts for two things. This UV sterilizer right here, it's an ultraviolet light. It kills bacteria and viruses. There's the wire coming into it, and I got a pump over here, which has a little motor on it, need it wired up so I can pump the water through the system. Contaminated water would be here at the top, in this NC State bucket, if you will. And it's flowing by gravity right now. I'll turn the pump on in a minute. It's going into the pump, comes out of the pump, discharges at the top, and it goes through these two-stage filters. Now, it'll flow by gravity for a little while, but that doesn't give us much of a flow rate, so we'll have to turn the pump on here in a second to really get it moving. You can see the water flowing into the tubing coming out of the filters. So we got it filtered. That's a good deal. But we need to kill the bacteria in there and the viruses, which you can't see. Sometimes particles you can see. The really bad actors that do harm to our bodies you can't see. And here's the clean water coming into this orange bucket. This is drinkable water in this bucket. The NC State bucket is not potable water. Let's turn the pump on. Got two controls here, one for the pump, one for the sterilizer unit. You can hear the pump running. So now we're pushing some water. We got about 5 GPM or more pumping through this guy. That's enough for a family, and enough for drinking water and cooking water and that sort of thing for a family. And that's good water. And then we'll come over and turn the sterilizer on. And it's got a window down here on the UV module. And if I can focus this camera for you, it's dark right now, which means the lamp is off. So once I turn it on, that will become a light green. There you go. So the lamp is on. If that doesn't come on when I flick it on, then I need to change the lamp. There we go. There's another on-off just to show you that it is working. Kills 99% of the bacteria. We tested the water, contaminated pond water, before and after this unit, and we got a 99% kill rate. So these units are desperately needed overseas. And like I said, there's about 800 million people in the world without access to clean drinking water. And this will, help solve that problem. It does cost money. They are available in a modular, compact form. This is just kind of a demonstration portable unit that my kids and I wanted to do the math, to run the math calculations for pressure and flow, learn a little bit about electricity, amp current, volts, and power with watts. To make sure our battery was big enough to power what we wanted to do, we had to do a little calculation there. We also had to do some chemistry. We had to measure pH, bacteria, nitrates, etc., in and out to make sure the system was effective. We checked organics as well, particulates. And so there's a lot of different science and chemistry aspects associated with this. This bacteria, it's killed by its DNA. This UV light disrupts the DNA of those organisms, and that's how it is effectively killed. So there's biology, chemistry, math, all integrated into this project-based activity. So let me finish this video out for you and we'll be done with this. So if you think you'd like to have your student involved in these kinds of activities in addition to the regular math and science curriculum, here's where you need to go. We're Vision's Virtual Math and Science Center, and there's our website right there, visionsvirtual.org. All righty. I think that's it. Thanks for listening to me.